All right, so today we're going to talk about gravity and terminal velocity. So the first question I have to ask is, when looking at, an astronaut up in the space station, is there gravity acting on that astronaut? So, in a space station, in orbit around the Earth, is there gravity? So take a couple of seconds, think about it, and we will talk about this answer in just a little bit. So first of all, before we can address this, we first of all have to talk about what a force is. A force, remember, is a push or a pull on an object. Gravity is an attractive force between any two objects that depend on mass and distance. Now, gravity is between every object, right? Gravity is between every object. And it's affected by mass and it's affected by distance. The more mass you have, the greater the gravity. All right, take a look at the Earth versus the Sun. Sun is way more massive than the Earth, therefore has more gravity. Well, then why is it that when I take and if I have my phone here, and I would have up the air and I drop it, if the Sun has more mass and has more gravity, then it should go up towards the Sun, right? Well, no, it didn't. Why is that? Why? Because not only mass is involved in the amount of gravity, but the distance. I'm way closer to Earth than I am to the Sun. So therefore, there's more gravitational force between my phone and the Earth than there is between my phone and the Sun. But there is gravity between every object. All right? So there is some gravity from the Sun acting on my phone, but it's a very small amount in comparison to that of the Earth, and therefore the Earth has more influence over my phone. Now, weight. What exactly is weight? Weight is a measure of the force of gravity, okay, on an object. So remember, force is measured in newtons, and we use a scale to do this. So if you wanted to, and weight and mass often get mixed up with one another. Because if I was going to take, and I wanted to go and if I was going to try to sell something like the ultimate weight loss program, you take them to the moon. Because what happens is, take a look at the diagram on below here, because the moon has less mass, it has less gravity. Therefore, weight, remember, is a measure of the amount of gravity. You're going to weigh less. So you can be like, yeah, I'm going to lose. You can lose 35 pounds instantaneously. Just do this one simple thing, which is go to the moon, but it would work. So on the same token, you can go to, say, Jupiter, and all of a sudden now, instead of having the force of gravity be, 9.81 like on Earth, it's 2,600. So you're going to be way heavier. So remember, mass is the amount of stuff in the object. So if I go to the moon and I go to the moon, my weight will change, but my mass doesn't, unless I lose an arm or something. Okay, so key here is that when you go to a different place that has different amounts of gravity, your weight will change, your mass will not change. So I want you to try this. Take a piece of paper, if you have an old textbook, try to create a way so that you drop the paper and you drop the book and they hit the ground at the same time. Try this little activity, pause it right now, and then hit play in a few seconds. All right, so if you do the activity, you maybe had 2, 3, 4 different ways. Well, what caused the paper to drop slower than the book? That's because of something called air resistance. Air resistance is the friction-like force that opposes the motion of objects as they're moving through the air. So it's going to be a force in the opposite direction. So if I'm someone falling, a skydiver, I'm going down, the air resistance is pushing up on that individual. Air resistance is going to be determined by a couple of things: the size of the object, the shape of the object. So if I take a piece of paper, if I crumpled it up, make it into a ball, I've changed the size, all right? I've changed the shape, I've changed the surface area. The speed of the object is going to have an effect on that. And then the density of the air, or the properties of the air. The less dense it is, the faster you're going to fall. Now, there's something called terminal velocity. Now, terminal velocity is the maximum speed that you're going to get when falling through a substance like air. So you jump off a plane and you start to fall down. As you can take a look here, you'll notice there is just the force of gravity on this blue here. But now you've got air resistance in the red here, your drag force, in the opposite direction. When the body is falling, at some point in time, the drag force and the force of gravity on the object are going to be the same, which means you're not going to fall any faster. Okay, because here we have the blue force is bigger than the red force, therefore you're going to accelerate downwards due to gravity. When they're the same, that's when your velocity, your speed, times out. For a human, it's around 122 miles per hour, which you think about it's pretty darn fast. So free fall. Free falling is if there's no, if gravity is the only force acting on the object. There's no air resistance. Remember, force of gravity, or acceleration due to gravity, is 9.8 meters per second squared. All right. So if I were going to calculate free falling, I would take F, the force of gravity, times mass times gravity, which is 9.8 meters per second squared. Free falling. This is what's happening in our question that we asked at the beginning of this lecture. The people in the space station are actually falling towards Earth at 9.8 meters per second squared. So, like if you ever, and I'm not condoning this at all, right? But if you've ever seen someone, jump off a cliff into the water, into a lake or a river or a bridge, all right? If you have two people next to each other and they both jump off and they're far apart, can you move over and try to grab them? No, you can't, all right? Just like an object, somebody in space, unless they get a push off of something, they're going to be kind of floating up there. Or we've all done this in an elevator. Right before you hit, or after you hit the down button, what do you do right after that? All little kids love to do this. I still love to do this. What do? You jump up right at the time, right after you hit the down button. Why? Because as you jump up, for just a split second, you feel like you're weightless. So what's happening is the object, the person is falling towards the Earth. And that's what's happening with the astronauts. Well, if that's the case, then why don't they, fall into the Earth and well, because what's happening, there you go, because of this. The object is moving, people are moving so fast in this direction, all right, that they have a curved path, all right? So gravity is pushing them this way, but they're traveling at extreme velocities in this direction, which gives them a curved path, which we'll talk more about at a later lecture. And so therefore, that is why they go around the moon. And so if they go slower, they will end up crashing. So that's the gist of it. If you have any questions or want to see any of the links found in the video here, in the slideshow, click on the link down in the description and you can watch that slide presentation. All right, have a good one.